Let's reverse the process then and see how the universe is doing its thing. The universe was incredibly smooth, dense, hot, with tiny variations. Those variations grew into huge superclusters in which lots of stars formed, including such large stars that they ended up as black holes. Those black holes would be in those huge galaxies. Some of those galaxies merged, creating other galaxies. And as the universe was expanding, galaxies interacted less and less. Basically, the uniformity, the smoothness has gone way and way less, and the universe is less and less smooth as time goes by, until at present not only do we have galaxies, stars and planets, but we also have smaller details such as continents, countries and people. In terms of time, basically the distance between two objects has been growing dramatically from the time of the Big Bang, which we basically just reverse the time and go until two atoms were joined at a heap, and until the present day. I kind of like that picture because it gives you sort of a feeling of the fact that the universe not just was hot and dense, but that it grew in size and got reduced in temperature exactly at the same rate. But what is the geometry of the universe? And you're asking yourself, what do you mean by that? Universe is three-dimensional, isn't that right? Well, not exactly. It's not at all clear. You may remember in the beginning that I said that the observable universe could be just part of an infinite universe, but doesn't have to be. It could be that the observable universe is what we call a closed sort of space. Probably the best example is Meissner space. Meissner space is a weird space. Basically you go straight till you find yourself in the same place, or you look straight and you see the back of your head. Only of course you would die, because it takes 20 billion years until light would come and see the back of your head. You look up, you see your bottom of your feet. But unlike the case near a black hole, you look to the left, you see the right. So in all three dimensions you can close a circle in a sense. That is a possible, just possible geometry for space. There is also something called the settled space and flat space. Flat space is just what you're thinking of when you're thinking of three-dimensional space. As I mentioned earlier, the universe is accelerating its expansion. The main culprit that is responsible for accelerating the expansion is now assumed to be something called dark energy. We don't know what it is, and we're very uncomfortable with it, but it constitutes about 70% of everything. Of the rest, more than 20%, more than 29% are what's called dark matter, which means material that doesn't shine and is not protons and neutrons and electrons. And only a fraction is matter like us. We still don't know what dark matter is, we don't know what dark energy is. Therefore, we are in many ways still in the dark on how that universe of ours is functioning. This is not at all close to our understanding of how the solar system works. Late last year I was in a conference that took this picture below and made it even a tad tighter. Basically we have some independent confirmation about those two weird energies, negative energy and dark energy, that still are making us see a lot of evidence that that's the case. We still don't know what makes it work. This last slide is part of research that I started about 15 years ago, exactly when that evidence for the acceleration of the universe was first presented. If you are interested in it, I would be happy to speak with you about it. For the time being, this is the end of our last lecture. I had a great time talking with you over on the phone. I enjoyed a lot of your comments on the forums, and I had a very interesting time preparing this online course. Interesting in great ways, in not so great ways. But all in all, it was definitely an enriching experience which I'm going to make a lot of use of. I thank you very much for all of your suggestions, and I wish you great luck in the final. Please take your time on the final. All of the slides will be available. Questions are from both the book and from my own test bank, and I would expect you to work on it on your own, of course. I don't doubt you would do that. Again, I hope you'll have a fantastic time for the rest of the summer, and as I do finish each of my classes at Baker University, I'll do so here. May you live long and prosper.